Welcome to my limits video. Okay, so you may be wondering, what's a limit? Well, it's a good question. Okay, I think I can illustrate it best with an example. So, imagine you're here, you're standing on the x-axis, okay, and you're walking along the x-axis towards the right. So you have a flare gun, and every time you stop, you shoot the flare gun up. So, as you would imagine, the flare would hit this curve here at certain points, because as you're walking and stopping on various x values, you're hitting various y values directly above those x values. Okay, so in very basic terms, that's what a limit is. So you have some function f of x, and for every x there's a y value. So the limit in a very basic sense is the y values that come out of the function when you plug in a certain x. Okay, so easy enough. Now I'll get into a better definition of it in a few minutes once I explain here a few of the ways to solve for limits. Okay, so there's the graphical method, which we basically use here. I didn't tell you expressly what the limit was, and I'll tell you in a minute. First, I just want you to see it in this numerical way. Okay, so using a table like this. So there's the graphical way here with this graph, finding a limit, and then there's the numerical way. Well, there's another way, and I'll tell you about that in a minute. Well, I'll just say it's the analytical way to evaluate limits. Okay, so back to here. So this function here, this curve is, it's a hard F. Okay, so f of x is equal to x cubed minus 1 divided by x minus 1. Okay, so we're plugging in different x values into this function and seeing what comes up. So if you plug in 0.8, you get 2.44. If you plug in 0.9, you get 2.71, and so on. So what we're actually doing is taking x values that are to the left of x is equal to 1, well, the point on the graph that corresponds to x is equal to 1, and values on the right of it. So, as you can see, these values are smaller than 1, and these values are bigger than 1, so we're trying to go into that point from the left, going towards it, so small to large, and to the right, from the right, in on that point, so large to small. Now, you notice here, the f of x values get closer and closer to 3 on either side. So as x tends to go to 1, then f of x, or y, tends to go to 3. Okay, so I kind of showed you the graphical way, and I just showed you the numerical way. Okay, so in in some other video, I'm going to talk about the analytical way, which involves a lot of algebra and things like that to make this into a proper form. Okay, so I kind of went backwards. I was showing you stuff about limits before really telling you what a limit was. Okay, so alright, let's see. So now take what I said before, and I said that as x goes to 1, then f of x goes to 3. So now we can say that informally the limit of f of x as x approaches, and that's what this arrow is, approaches c from either side, left or right, it's equal to L. So this says the limit of f of x as x approaches some number c on the x-axis is equal to L. So this is basically saying that as x tends to c, f of x tends to L. So as x starts approaching 1, then the values f of x start approaching 3, as you can see graphically and as you can see numerically. Okay, so for our specific example, we can say the limit of x cubed minus 1 divided by x minus 1 as x approaches 1 is equal to 3. So this is the informal definition, so when you see problems in textbooks and on tests, you'd see them, a lot of them will be in this form, but it just won't tell you the limit. So it will just say the limit of this function as x approaches 1 or whatever number is what. So you have to try to solve for that. And you may get a few problems maybe with some numerical solutions such as this. You'll get some x values and you'll see which y values come along. So you'll get some graphical solution, homework problems and test problems, and you'll get some analytical numerical solution, homework problems and test problems. Okay, so like this and like this one. Okay, so in the next video I want to go over some problems that you may be likely to get on the test or in homework. And so we'll go over some graphical solution problems and some numeric solution problems. And then after that we can talk about the analytical way to evaluate limits and the different limit properties that help us out in finding limits, and different techniques such as factoring to try and kind of deconstruct this function f of x into a form where we can basically just plug in the number that x is approaching or whatever variables approaching and not get a division by 0 like in this problem here. So that's why there's this hole, and that's actual calculus terminology, a hole in the function at x is equal to 1. There's this hole there. Okay. Okay, so there's that hole, and so we and as you can see from the function, that this function is not defined when x is equal to 1. So x cannot be equal to 1. Otherwise, division by 0, the earth explodes, we get sucked into a black hole, whatever actually happens, I don't know. But yeah, so we can't do that.